This is Professor White. Today we will talk about distance problems related to systems of equations. Let's get going. Write down the meaning of x, y, and z, put down the equations, solve, and then check. Alright, well there are a couple of things you need to remember. Rate is distance over time. One way to remember that is miles per hour. You go miles, that's distance. Per means divided. Time means time. 55 miles per hour. Distance divided by time. If you work this out, distance is going to be rate times time. This means times. Or if you want to write everything in time, time is distance over rate. So as long as you remember that, you're going to be okay. So let's look at a couple of problems. A Vermont Railway freight train leaves Boston, heading to Washington, D.C. at a speed of 60 kilometers per hour. 2 hours later, an Amtrak leaves Boston, bound for Washington, on a parallel track at 90 miles per hour. At what point will the Metroliner catch up to the freight train? Okay, so let's look at that. So the first train leaves Boston. Here's my Boston. And heading to Washington, D.C. Here's my train. Okay? And he goes 60 kilometers per hour. All right? So I put that down. 60 kilometers per hour. Now what happens is 2 hours later, so 2 hours go, so this guy is kind of like here. This is first. 2 hours later is 2 hours later. Okay? The second guy, all right, that 2 hours later, an Amtrak Metroliner. Okay. Okay, hold on. I want to get something done. All right. Amtrak Metroliner leaves Boston, bound for Washington, D.C. on a parallel track at 90 miles per hour. It's going very, 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 very fast. 90 kilometers per hour. All right? At what point will the Metroliner catch up with the freight train? At some point, they are going to catch up. And that distance is going to be, remember, even though this one left 2 hours later, the distance is the same, right? So they both traveled d distance. So let's put that down. Now, if you want to put things a little bit, maybe I want to do, let me get another paper. All right, so let's go and let's put down here. Okay. Sorry to make you, so I have two unknowns. The distance I don't know, and I don't know the time. At what point will the Metroliner catch up? Okay? Let's go and do that problem. At what point? That's kind of difficult. Are they asking me the time or are they asking me the distance? Well, you might as well answer. Probably they're asking at what point in time will the Metroliner catch up to the freight train. Okay, so let's write it down. Now, the first train goes 60 kilometers per hour and it goes for t time. So d equals 60 times time. Does it make sense? Let's go write down the second equation. Now we are going Metroliner. D equals, he goes 90 miles per hour, but he's going to travel 2 hours less, t minus 2. Okay, well, can I solve these two equations, two unknowns? Since they are both d's, I can set them equal. So let's do that. 60t equals 90t minus 180. Move the 90 to the left. Negative 30t equals negative 180. Divide both sides by negative 30. T equals 6 hours. All right. So what happened? This is what happened. Freight train traveled 6 hours. And Metroliner traveled 4 hours. Okay? If you want to tell them what the distance they traveled, so you can go, the distance is going to be 60 times time. So it is 60 times 6. They traveled 360 kilometers. All right? So that is one type of problem. So I put D and T as unknowns and solve it. Let's go to another, look at another type of problem. Those are the type of problems that are like either tailwind, headwind problems, or you are rowing against or with the current, or you are in a little boat with the current, or you are on an escalator going up or against because you want to be a fool and kind of go get yourself hurt. So those kind of problems. You are going with something or you're going against something. So that can be current, that can be wind, that can be a moving conveyor belt. All right, let's look at that. A Boeing 747 jet flies 4 hours west with a 60 miles per hour tailwind. Here's your plane. East-west, he's going west. And with a 60 miles per hour tailwind, that means the wind is helping you. 60 miles per hour. Okay? Returning against the wind takes 5 hours. So he goes from here to here in 4 hours. Because the wind is helping him. Now he's coming back. So he's coming back. And the wind is still blowing that way. And this time, since he's going against the wind, it's going to take him a little longer. 5 hours. So that's the situation. Now, going backwards or forward, the distance are the same. They just travel the same amount. Okay. Now, when you go with the wind and you're going the same direction, R is the speed of the plane. So you might want to write this down. R is the speed of the plane in no wind condition. So the plane, if he was in a vacuum, he would go that fast. Okay? When he goes with the wind, it's going to help him. So it's a plus. When he goes against the wind, it's going to be hindered. So here's my rate in both cases. What is time equal to? It tells me the time is 4 hours versus 5 hours. Okay, well, I can handle that. So what are my equations then? Okay. Let's move this up. Okay, the first time when I go with the wind, my distance is rate times time. My rate is R plus 60, and my time is 4 hours. Going against the wind, my distance is going to be my rate minus 60, and it's taking me longer. Okay, how do I solve this system? Since they are the D's, do substitution. R plus 60 times 4 is R minus 60 times 5. Work it out. 4R plus 240 is 5R minus 300. So let's work it out. Let's take out 4R. you're going to have 240 equals R minus 300. Okay, and then add 300. Then R is 540. 540 what? 540 miles per hour. So the plane goes 540 miles per hour. Does that make sense? Yeah, that does make sense. That is a reasonable rate. Find the speed of the plane with no wind. That means, like, the plane would go that much without the wind in a vacuum. So I actually did answer the question. If you want to double check, you can go and double check and make sure that, so with the wind he goes 540 plus 6600, and then without that, and make sure you multiply these two, you get a D, and multiply these two, do you get the same D? And I did check that for you, and it actually does work.